By its nature, discrete quantized audio is a one-dimensional signal. Even when we're processing multi-channel tracks, there may still be dependencies between channels, for example, in mid-side panning. This limits our usage of a classical GPU approach, as most GPU-accelerated algorithms use independent dimensions. For example, even in image processing, we have width and height, x and y. In most audio production scenarios, audio processing is being done on some kind of buffer. If the processing buffer in this case is 96 samples in size, we can get the whole buffer in our processor at once. This brings us the possibility for parallel calculation, the ability to calculate all samples in parallel by allocating at least one thread per sample. However, many classic DSP algorithms have data dependencies, which again forbids us to do so in many scenarios. Simply put, data dependency means that some form of the sample of a signal is dependent on not only on the current previous inputs, but also at least one previous output as well. You can think of this as a function which depends on one or more derivatives of itself. This forces us to open our DSP algorithm toolbox and group all of the content into two buckets, without data dependencies and with them. Without data dependencies directly translates to a classical engineering problem, and we can start off writing nice performant GPU code. With them, however, needs to be studied further.